Hey everybody, welcome to Video Notes 3.1, where we're going to cover covalent properties and naming. So here's the 5 things that this video should help you be able to do. Please read these sections of the book and do this one self-check problem. Oh, that's what your book looks like. Yeah, well, I'll find it. All right. So why do atoms make bonds? Atoms make bonds to be more stable. And stability happens when a valence shell is full. So the number of valence electrons fills up an outer shell. So here's fluorine. Fluorine has 7 electrons. And so it has 9 total electrons, but 7 in its outer shell. And so if it gets one more, just one more, it'll have 8 valence electrons. 8 is great. So if this fluorine atom with its 7 outer electrons and this fluorine atom with its 7 get close enough together so that they can share those two, then they can make a bond and be more stable. And now this fluorine can count that blue one as part of its 8, and that fluorine can count that red one as part of its 8. Oh, here's hydrogen with 1 valence electron. Here's chlorine with 7 valence electrons. Can these two atoms work together to make a bond? They sure can. Here's hydrogen's 1 and chlorine's 8 and 7. And if they share these two in between them, then every atom is stable because this one has 8 and hydrogen has 2. But hydrogen only needs 2 to fill up its outer shell because it's got that first energy level. Right, so if we look at fluorine, 1s2, 2s2, 2p5, and another fluorine, 1s2, 2s2, 2p5, if they share their outer shell, then these 7 and these 7 sharing together, one of their electrons makes 8. Okay, now these fluorines are pulling on those pairs of electrons equally, that pair of electrons equally, so they're sharing that equally. But over here, chlorine is pulling on that pair of electrons more than hydrogen. So they're sharing them, but chlorine's kind of hogging them towards its side of the bond. All right. So this is called equal sharing. Equal sharing. Special word for that. If sharing's going on and it's equal sharing, it's called non-polar. Covalent bond. Covalent bond. You'll define it later. Oh, that should be bond, not bond. Really? Okay. This is unequal sharing because one atom is pulling more on the shared pair of electrons, and unequal sharing is called polar covalent bond. So remember, we'll define it a little more later. Down here, what happens? Well, here's sodium. It only has 1 outer electron. It's a metal. Right? Here's chlorine again. We use chlorine up here, but now we're using chlorine over here. It has 7. Sodium has 1 valence electron. Chlorine has 7 valence electrons. How can these atoms work together? Well, if sodium transfers its 1 outer electron to chlorine, and sodium becomes a +1 ion, chlorine becomes a -1 ion, but now chlorine has a full outer shell, and then sodium's inner shell is full. So the 1 outer electron, sodium was like neon with a 3s1, and then chlorine is now more like argon because it has 18 total, but 8 outer electrons. This, when an electron goes from one atom to another, completely transferring, it's called an ionic bond. So, how do atoms become stable? By sharing electrons equally, sharing electrons unequally, or totally transferring electrons from one to another. Okay. So, what decides, or what property helps decide whether atoms are going to share or transfer? Well, it's electronegativity. Luckily, we know the trend in electronegativity. Electronegativity is, find fluorine on your periodic table, that is the most electronegative atom. So electronegativity gets bigger going towards fluorine. Remember, this group doesn't make bonds, right? No bonds. So if two atoms have about the same electronegativity, the same pull on their another atom's bonded electrons, then they're going to share them equally. If one atom is a little more electronegative, okay, the difference between the atoms, one is a little more electronegative, then they'll share electrons, but one atom will pull them towards its side of the bond. So this is equal sharing. This is unequal sharing. And then if one atom has a really high electronegativity compared to the other one, then we'll get ions. So it's like a continuum of bonding based on the electronegativity differences of the atoms. But you'll find out that here's polar bonds, nonpolar bonds, and ionic bonds in words. I'm sorry, in kind of pictures: equal sharing, unequal sharing, transferring. Here it is in words, all right? So covalent is sharing, and you could share equally, start sharing unequally until you get to ionic. It's a continuum, all right? END stands for electronegativity difference. So what's the difference between the two atoms? So if you subtract them and you get a difference of 0 to 0.4, it's pretty equal, nonpolar, that the atoms share the electrons. If it's a pretty big difference, I mean bigger than this, but in between, really big, then they're going to share, but the higher electronegativity atom will pull more of the electrons towards itself, and you get poles created, and that's called a polar bond. And then if there's a big difference in electronegativity, 2 or greater, then the electrons will get transferred from low electronegativity to high electronegativity. All right, so where do you find electronegativity? On the periodic table that you've been using, it's these bottom numbers, right? So what is the NO difference? So you got N is 3.0, oxygen is 3.5. What's the diff? 0.5. Now we're doing absolute value of difference. So it doesn't matter how you subtract them, you're going to get 0.5. It says 0.5 is polar, so this is a polar covalent bond that they make. FF. Well, we got the biggest 4.0, 4.0, so they're going to equally pull on the electrons because what's the diff? 0. So that's called a non-polar covalent bond. Non-polar covalent bond. Polar covalent bond. Ionic bond. Okay, lead and fluorine. Fluorine's got a 4.0, lead's got a 1.0. It's a 2.2 difference. That's a big difference. So fluorine, because it's bigger, is going to take the electrons away and make an ion. Okay. C and H is 32.5 and 2.1. What's the diff? 0.4 is the diff. So this is going to be a non-polar covalent bond. That means we're going to share the electrons pretty equally. All right. Look, a table of all electronegativities. Don't copy that. Remember, you have one. But I just want to show you. Look at small electronegativity. A long word to write. Big S electronegativity. I'm spelling it. Okay, so not metals and non-metals are going to make ionic bonds. Metal reacting with a non-metal, the non-metal is going to take the electrons away from the metal. Two metals working together will pretty much share. So metal, non-metal, ionic. That's just a guideline, right? And so is electronegativity, but then you have non-metal and non-metal covalent. Pretty much, okay? We can predict. So, let's talk about covalent. Look, sharing. Oh, look at them sharing here. That's so cute. So, covalent bonds. Sharing electrons. It happens with non-metal atoms because they have similar electronegativities. So a lot of times the covalent bonds that we're talking about are directional covalent bonds because the valence electrons that are shared are centered between the atoms that are sharing them, and they can't flow all the way through the compound or crystal or whatever they're making. How do we know how they share? Well, they fill an octet, get 8, except for hydrogen, right, which only needs 2, and there's a few other exceptions we'll get to. Then once they're sharing them, then those valence electrons can count for each atom. So look, it's NH3. They're both nonmetals. Nitrogen has 5 valence electrons. Hydrogen has 1 valence electron. So if you can get nitrogen to share with hydrogen, we'll learn how to do dot structures later. So this is a shared pair of electrons. And then hydrogen's happy because it has these 2 to share because of minus 2. And nitrogen's happy because it has 1, 2, 3, 4, 5, 6, 7, 8. By sharing 1 from each hydrogen. Okay. So covalent bonds. They can atoms can share electrons to make little molecules. Like NH3 is a little molecule. Oh, look, it's a little molecule. Right? H2 is a little molecule. Oh, look, we're sharing like a little molecule. But then electrons can be shared between nonmetals to get a network, right? So carbon sharing with another carbon, 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 on and on and on and on. You can get diamonds. It's called a network covalent. Sharing electrons can make long chains of molecules like polymers, like share, 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 on and on and on and on and on and on. And then you get the spaghetti, and this is a loose technique. Okay. What would you see with compounds and molecules that are sharing electrons? What do you see if covalent bonding is present in matter? These are general characteristics, but in general, the bonds that are forming happen from nonmetals sharing electrons. All right, you see nonmetals involved. You're not going to see many metals in covalent bonding. Because they're sharing electrons and electrons can't move, they pretty much are not electrical conductors. They could have high or low melting points, but covalent compounds are the only ones that will have low melting and boiling points. Okay. So it can range, but if you do have a low compound or an element or a molecule that has a low melting point and a low boiling point, it's because of covalent bonding. Now, we're going to learn why, but there are polar covalent substances and there are non-polar covalent substances. The polar ones are soluble in water. And then many covalent things do not dissolve in water. Okay, the bonds between atoms are very strong in covalent bonding. But once you have those little molecules, what's holding the little molecules together is a different story. Okay? All right, so electron configurations can help us predict what kind of bonds atoms and molecules will form. Well, form between atoms to make molecules. So this is oxygen's orbital diagram. Here's oxygen's orbital diagram flipped over. But if you notice, there's two places where oxygen needs to get an electron. Another oxygen atom has two places where oxygen needs to get an electron. If this overlaps that, then they come together, and then these two red ones will be over here if they're sharing them, and they come together to make a molecule. Same with hydrogen. One hydrogen and another hydrogen come together to make a molecule, and then each hydrogen shares in these two. This is nitrogen, okay, and this is nitrogen. Three places where nitrogen needs to gain electrons, or it can share three of its buddies, okay, and then if you overlap these two atoms, then this goes there, this goes there, this goes there, and they share them, then each atom has 8. So if they're sharing more than one pair of electrons, you get what are called multiple bonds. So hydrogen only makes a single bond, and this is 2 electrons. 2 electrons being shared. A double bond, 2 electrons, 2 more electrons. So a double bond is 4 electrons being shared. Okay. And then a triple bond, 2 electrons. Uh-oh, are there more? Yeah, 2 electrons. Uh-oh, are there more? 2 electrons. All right, so a triple bond is 6 electrons being shared. And atoms can do this because then it makes them have an octet. And that's what's happening here. In order for these 3 to overlap those 3 so that you get fill up both by sharing, then it's going to make a triple bond. Okay, so what do you think stronger, a single, double, or a triple bond? Well, if you want to break them, it's going to take a lot of energy to break all 3 of these bonds. And because they're sharing so many, these bond lengths are shorter too. Okay, so what do we call these molecules that are being formed with covalent bonding? Okay, so molecular compounds have covalent bonds. Covalent bonds. Okay, and in order to be a compound, you have to have 2 elements. 2 elements at least. Okay. Molecular compounds we're going to look at are really called binary molecules. They have 2 elements. So we're looking for nonmetals only, 2 nonmetals. We're going to use some prefixes to tell you how many atoms are involved. So you have to memorize what these prefixes mean. Mono means 1, 2, di is 2, tri is 3, 4, pent is 5, hex is 6, hept is 7, octa, oh, like an octopus 8, nana 9, and deca is 10. Decade is 10 years. Okay. And then the second word of a compound that has 2 nonmetals is going to end in IDE. So let's use a poster child for molecular compounds. It's going to be CO. CO is carbon monoxide. You may have heard of it. It's deadly. You gotta avoid it. And you should get a carbon monoxide detector in your house. So CO is carbon monoxide. If you understand this one, you just have to memorize your prefixes for the rest. Okay, what you might notice is that if the first atom is singular, you don't have to put mono in front of it. No mono. Also, when you do put mono on the second one, because there's only one oxygen atom in this molecule, we call it monoxide, not monoxide. No double O's. Right? So that's a couple of rules of carbon monoxide, your guy. Here's some more molecular compounds which have covalent bonds. Here's how I know. Non-metal sulfur, non-metal fluorine. Two nonmetals are going to bond covalently. Oh, there's only one sulfur, so I don't need I wouldn't say monosulfur because I don't need mono on the first, so I just call it sulfur. And then the second one is fluorine, but I changed the N to IDE, and there's 6 of them, so it's hexa fluoride. Spelled fluoride, right? It's got the flu, F-L-U. Okay, non-metal, phosphorus, because there's only one, and I don't need mono on the first. If it's any other for one, I'll show you in a second. 5 chlorines, it needs to be I. And 5 is pentachloride, right? Phosphorus pentachloride. Okay, non-metal. Please treat hydrogen as a non-metal for most of what we do. And so there's 2 of them. So I do have to put a prefix if it's more than one. Dihydrogen. And then there's one oxygen, not mono, monoxide. Okay, remember to change the ending. Prefix. If it's mono on the first, you don't need to write. Hey, this molecule says decanitrogen monoxide. Deca means 10. Mono means 1. So I have 10 nitrogen, N10. N10, that sounds fun. Oxide comes from oxygen. And how many? Just 1. It's N10O. Alright. Trinitrogen, 3 nitrogen. Mono, 1 sulfide. Boom. Hexa, 6 sulfur. 6 sulfur. Di for 2. Chloride comes from chlorine. Okay? So use your prefixes. Alright, now you need to memorize these, but this is a pretty colorful picture of the diatomic elements. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, we don't change their name when we call them this is their name. Oxygen is O2, nitrogen is N2. Hydrogen is H2. These molecules are how you'd find these elements in nature. You won't walk up to a hydrogen and it's just one H. It's always bonded to itself. So they use each other to fill their outer shell by overlapping to get their valence set. So these are called diatomic for 2 atoms that make up an element. So the atoms have to be the same. H and H, N and N. Oh, look at her. H, H, N, N, O, O. Should I keep going? F, F. You're like, why are these so long? Because she doesn't stop. I, BR, BR. Oh, that's hard to see. CL, CL. Okay, these are diatomic elements. Memorize. Oh, take a mental picture of this slide. But then you can also use a periodic table. So if you want to know the diatomic elements, you start with, there are 7 of them. Look, 1, 2, 3, 7. Start with element 7. Go over and down. Oh, look, it makes the number 7 on your periodic table. Wait, it's only 6. Oh, it's pointing directly. Okay, that's a stretch, but it's pointing over the hydrogen. So you can use a periodic table to help you find the diatomics, or you can memorize this word, which is coming up, Nafkulbrich. So Nafkulbrich, you have to emphasize the H or you'll forget it. So you gotta like phlegm it up a little bit. So Nafkulbrich, or N-O, F, so it goes in order that they are and points over to hydrogen. So you gotta phlegm up the hydrogen to remember it. And whenever you have these elements in nature, they're really gonna be their diatomics. Okay, so please read the book, sections 12.1 to 12.4, and do this one self-check. Oh, how can you do that page? There's not that page. This got in there accidentally. Oh, it's not an accident. Look, it's a red balloon. Yay. Okay. So anybody, covalent bond yells an ionic bond? Did anybody ever teach you to share? Okay. these are the 5 things we covered. Hopefully you'll get them, and we'll talk about them in class. And you're going to see 2 slides really quick because we'll talk about those in class. Peace out.